Electronics programming with the Commodore 64. In this video, we're going to look at blinking an LED using the Commodore User Port. The Homebrew Computer Club, the Altair 8800, the IMSI, the Apple I, even the ZX80, they came as kits, and so electronic skills and computing went hand in hand. Whereas my generation of computer nerds got started with easy-to-use, user-friendly computers that were supposed to be all ready to run. We didn't dare tinker with electronics with these computers because our parents had paid for them, they were expensive, and they were precious to us. So very often we would flick through the magazines and the books in the library, but never actually put any of the knowledge to practice. And that's one thing I want to change for you today. That said, there were a lot of projects with microcomputers in the 1980s, combining electronics, programming, and the popular computers of the day, such as adding sound to the Commodore PET or the Apple II, joystick interfaces, light pens, even home automation. Like many computers, the Commodore series had a user port or an expansion port. The VIC-20, the 64 had both. Just like the Arduino or the Raspberry Pi, you had pins that could be inputs or outputs that could be controlled through programming. If you go to Future Was 8-bit, you can get a user port adapter for very cheap. They're going to help you with these projects, make it easier to attach your electronics to the port, hopefully without shorting anything out. As you can see, the top row are numbered and the bottom row are from A to N. For this project, all we're going to do is connect to the ground and a signal pin, and we're going to drive an LED. Even so, you have to be careful that you get the user port adapter the right way round and you connect to the correct pins. There is a maximum of 100 milliamps for any one pin to draw, and as a total, you shouldn't draw any more than 450 milliamps. And for that reason, I'm using my Ultimate 64 because it's a brand new machine, it's modern electronics. You might want to use a bare metal 64 using a Raspberry Pi, and that actually would allow you to switch between different Commodore models easily also. If you do use an original Commodore 64, and here's a couple of my original Commodore machines, just be very careful that you connect to the correct pins and you don't draw too much current. For that reason, I'm going to use a 1000 ohm resistor, 1K resistor, which is way over spec, and I'm going to use a tiny LED, which shouldn't draw too much current. All we're going to do is connect ground and pin PB0. PB0 is found at location C on the bottom row. I'm using a breadboard, I'm using my adapter, and I'm using the user port cable for the Ultimate 64. But here's how it looks on a real Commodore 64. Once connected, you can power up and you'll see that the LED lights up. And that's because the default state of the pins is in this configuration. Don't worry and think that you've already made a mistake. Once we have it set up, we can do a poke to set the input and output on the direction register. And this should also work on the VIC-20 and Commodore PET too by changing the addresses appropriately. And once we've set the direction, we can actually turn on each individual pin, and because we're using pin 0, all we have to do is enter a 1 or a 0 to turn it on or off. Each of these pins is actually addressed using a byte, so between 0 and 255, each pin from pin 0 to pin 7 is addressed using binary. So we can selectively set each pin on or off, input or output, and that's going to be very useful as we do more advanced projects. But for now, all we're doing is setting all the pins to be output. We turn pin 0 on, wait for 100 loops, turn it off, wait another 100 loops, and then go to 20. Do it all over again.